So hello guys, welcome. Today we'll see how to do hydrocarbon test with methanol. So first you have to bring a wall wash sample from your tank. So this is my wall wash sample. I've written the tank name also here. So at least 50 ml or 100 ml is required methanol sample from the tank. So that's what I've already brought it. So now I'm going to test this in my tubes. Make sure all your tubes, whichever you are using, those are already washed with methanol. They are clear. The tube itself is not contaminated. So rinse it properly with methanol. Make sure there is no discoloration or anything which is present on the tube itself. So now there are many ways in which we can do this test, because it depends upon the stringentness of the port at which we are going to perform this wall wash. So the most stringent one which is preferred is 50:50 ratio. That means 50% of your tank methanol and 50% of your DI water. So this is considered as most stringent one.
So before going any further, I would like to just elaborate this hydrocarbon testing a little bit. So basically, to test hydrocarbon in a wall wash sample, what we have to do is we have to add methanol plus DI water, that is deionized water. And once we add this, we'll get a reading of hydrocarbon, whether we have hydrocarbons or we don't have hydrocarbons. So now this adding can be done in any form. Like if you want, this is tank methanol. That means a sample which is taken from the tank. So we can add 50% of tank methanol plus 50% of DI water, and it will make a ratio. We can add 10% of methanol and 90% of DI water. That will make a sample. Or we can add just 25% methanol and 75% of DI water. So we can do this hydrocarbon testing by any of the given method. So as per ASTM table, this is the one they have recommended for testing of hydrocarbon. In this format, 10% of methanol we have to add and 90% of DI, and then we have to check whether we have hydrocarbons or not. But this is not the case in ports. The most stringent one which we normally can get on a ports is 50% and 50% ratio. That is 1:1 ratio, you can call it. So in there we have to add 50% of methanol and 50% of DI water. So this is what we do on board. Considering the stringent one, we always do our test for testing of hydrocarbons in this ratio, 1:1 ratio. Now about this ratio also, we can do this test in a 50 ml tube, we can do this test in a 20 ml tube or in a 100 ml tube. It can be done in any tubes, but as I've said in my part 1 also, I normally do my test in 50 ml tubes. So in this tube, if I want to do this 50%, it will be 25 ml of methanol, that is tank methanol, and 25 ml of DI water. This makes it 1:1 ratio. Again, if I wanted to do 10:90 ratio, then I would have added 10% or 10 ml of methanol plus 90 ml of DI. It would have made it 1:9 ratio. So same thing can be done over here also. So if here I wanted to do this 1:1 ratio, I would have added 50 ml of methanol, that is tank methanol, and plus 50 ml of DI water. So actually here we are using tank's 50 ml of methanol. So in this case, normally what happens is, if you want to do a multiple test on a tank sample, we would not be able to do it, because chances are less, because we would consume more methanol in this 100 ml tube. So that's why I normally perform this test in a 50 ml Nestler tube, adding 25 ml of methanol and 25 ml of DI. So because if I want to do 2-3 tests or multiple tests, then I would still have certain sample with me as compared to the 100 ml tube, because normally from a tank, if we get 100 to 200 ml of sample. So that's why, as the sample is generally less, because we don't want to waste our onboard ship's methanol also, So normally I do my test on 50 ml of this Nestle tube. I hope you would have understand the ratios and the procedure to test this hydrocarbon.
So I filled my Nestle tube up to 25 ml. If you have more tank sample, then you can fill maybe up in a bigger tube of 100 ml. You can fill it up to 50%. It is your personal choice. So I'm filling up to 25 ml of methanol, and then I will add 25 ml of DI water. So that makes my ratio 50:50 ratio. So I have added 25 ml of DI water in this. So this is my tank sample. So for all our tests, always we have to make a reference sample. So in the same manner, we'll also make a reference sample. We'll add pure methanol. This is pure methanol or lab grade methanol, as you can call it. First I will rinse this Nestle tube. After rinsing it properly, then I'll add 25 ml of methanol. So I've added 25 ml of pure methanol in my Nestle tube, and then I'll add 25 ml of my DI water. So this becomes my reference bottle. With reference to this, I will compare my tank wall wash sample.
So normally when we do any test, either let's say we do hydrocarbon test, PTT test, or we do chloride test or any such test, we always make one reference sample. You can call it reference sample or you can call it as standard sample. The purpose of this reference sample is that whatever test we will do in comparison with this. So if let's say if I wanted to do a hydrocarbon test for a tank, one starboard, then normally, as I said, I normally add 50 ml of tank wall washed methanol and then 50 ml of DI water. So whatever is your test tube you're making, your reference sample should be also same, or vice versa, however you want to call it. So in this case, if I had made 50 ml of tank wall wash and 50 ml of DI water, here the reference sample, if I'll make it in a same manner, 50 ml lab grade methanol and 50 ml of DI water, and then I would compare them together. So always make sure that your standard is matching to your test tube. So it can be vice versa, however you like. Same in chloride also. If in chloride, let's say we add silver nitrate 7 drops in a standard solution, so make sure you add those exact 7 drops in this tube also. So your standard should be always matching to your test tube.
So this is my reference. I've just marked it with white paint marker, just so that it does not get mixed up. And this is my tank wall wash. After mixing it, we have to allow it to mix properly. For that, what we have to do is and allow it to settle for around 15-20 minutes. Let it mix properly, and after that we'll do the inspection. So now 15 minutes have passed. Now after 15 minutes, I'm going to check my tank sample and compare it with my reference sample. So once we are doing this, make sure you always do this in a background which is black color. So that's why we have prepared this black background. So we are going to compare this. I'll switch off my lights. So this is my reference sample. As you can see, it's crystal clear.
There is no turbidity or haziness in the reference sample.
And this also you can see, this is my tank sample, which is also clear.
So presently my tank was clean, hence you can see the hydrocarbon in the tank was also nil, or it was as clear as the reference sample. But let me show you another example where my tank was not clean and where we can clearly see the presence of hydrocarbon. So in this example you can see the glass which I am holding, that is reference sample with 0 hydrocarbon, and this is the tank sample where I have hydrocarbon of 1 to 2 FTU. So normally the hydrocarbon test is either pass or fail, but if you want to measure it in units, then it will be formazine turbidity unit, that is FTU. So just to show you different examples, here I have 4 Nestle tubes where you can see we have 1 to 2 FTU, 10 FTU, 50 FTU and 100 FTU. But please note that if you have 1 to 2 FTU also, your tanks will be considered fail for hydrocarbon test. Okay, but just to show you a clear picture, or just to show you different examples of FTU, I'm showing this, but in light it is not clearly seen. So let me just switch off the light. Here you can see how distinguishedly they are seen: 1 to 2 FTU, 50 FTU and 100 FTU. So this is just to see that how much impurity is present in your tank. So we'll continue to wash our tanks till our tanks are hydrocarbon free.
Looks okay.
And after that we'll come back to
Once
the
you've done your
example one
test,
where my tanks are free of hydrocarbon.
So once our tank are free of hydrocarbons, then we'll move to the second stage. There we'll perform chloride test. So for chloride, we have to have silver nitrate 5% solution, this, and nitric acid 20% solution. So now I will add 5 drops of silver nitrate and 5 drops of nitric acid in both in my reference sample and in my wall wash in my tank sample. To make it more stringent, some people add 7 drops into the bottle. So that's up to you. 1, 2, 3, 4, 5, 6, 7. We'll add 7 drops instead of 5 drops. 1, 2, 3, 4, 5, 6, 7. 7 drops we have added into this. Make sure the pipette tube which you are using are different for both bottles. Silver nitrate, it should be different, and for nitric acid it should be different. They should not be same. Chances are otherwise it will contaminate your main bottle. So same thing, 7 drops will add into each. 1, 2, 3, 4, 5, 6, 7. So after adding these, we'll shake both of these bottles well and allow them to settle for 15 minutes in the same manner how we have shook the bottle once we were doing hydrocarbon test. So now once we have shaken this well, we'll allow it to settle for 15 minutes and then again in a black background
We'll check for chlorides.
So now 15 minutes have passed. Now we'll compare both our reference sample and our tank sample behind a black background by switching off our lights. So this is my reference sample again, which we have made with pure methanol and pure DI. This is tank methanol, the sample which we have taken from tank, that methanol, and DI, pure DI. So I'm passing this. You can see it is crystal clear. There is no refraction or something. Here, this you can see it is little bit whitish in nature, and it has a small beam, small milkiness. And by this also I can compare by pointing it out like this, whether the beam is passing clear or not. So this chloride is less than 1 ppm, so that means my tank is almost passed. I don't have to do any more washing on this. So that's it with testing of chloride and hydrocarbon. I hope you have learned something. Thank you.